All right, just to remind you, so the top one right here, this is what we draw. So there are two steps here. So nucleophilic attack to form tetrahedral intermediate, break double bond, you get a single bond. Okay, sp2 carbon become sp3 carbon. And the second step is the remove or the loss of leaving group chlorine comes out. All right, so there are two steps here. Do not draw, put them into one step like that, because we actually, some cases, we can actually isolate the tetrahedral intermediate. Depends on the form, but it's not that form, but it is some other forms. Okay, we can trap that intermediate. And do not draw like an SN2. There are two steps here. The tetrahedral intermediate is formed first. If you draw like that, like an SN2, there's no tetrahedral intermediate. Okay, and you're gonna see this in biochem. So I'm not lying. This is real. So there's a look at our biochemistry. So look at this. So we have a polypeptide or protein. Okay, so polypeptide. So it got just a bunch of amino acids stick together with a peptide bond or amide bond. Can you see where is the amide bond or peptide bond? Right here. This is amide bond right here. Okay, this is amide bond. So CN right here. That's an amide bond. All right. So chymotrypsin catalyze the hydrolysis, so adding water to amide bond and break this amide bond, so you get two pieces of the this polypeptide chain. Okay, and this actually follow the nucleophilic acyl substitution. All right, so this reaction happened in the active site of chymotrypsin. So chymotrypsin is a serine protease, which means that got a serine in the active site. So serine is amino acid that got an OH group right there. Okay, so that serine will this enzyme catalyze the reaction. This hydrolysis reaction using serine is the main amino acid. Okay, this is happening in the active site. Let's take a look at the reaction mechanism. The substrate is in green, right, and the serine level in red. Okay, so you can see that. So this oxygen attacked at the carbonyl carbon of this amide bond. All right, so attack right there. And to form tetrahedral intermediate, so 1, 2, 3, and 4 look like tetrahedral structure, right? And so that's happened in the first step. So tetrahedral intermediate actually happened here. And then the next step, so we have to reform the double bond, so that take the negative charge on the oxygen from double bond here, and the amide comes off right there. All right, so amide comes off from out of the active side, you get the carbonyl carbon back. This is looking like an ester. Okay. The next step is water comes in. Water attack at the carbonyl carbon of the ester to form again tetrahedral intermediate. Yeah, so that's why you have to draw tetrahedral intermediate. It's actually happened. And the second step is reform double bond and expel the leaving group, which is the serine right here. There's a leaving group. Take a look, and you get carboxylic acid back and come out of the active site. Okay, so in biochem, you're gonna see a mechanism like this as well. So I'm not lying anything. So that's why you learn it. So we try to set you up before you take a biochemistry courses. Okay, all right, go to the next video. So we have the first carboxylic acid derivatives, acid chloride.